Okay, so I just want to end now on a special type of vector field. And we've actually done some work with these already. We just never called them a vector field yet. Right? And this is the gradient vector field. Right? Right. So, well, this is pretty much exactly what you think it is. Right? So, the gradient vector field, I'll just call that VF for vector field, of, well, let's say, f of xy. This is gradient of f equals fx fy. Right? If you have a function of 3 variables, this is now a vector field which takes in 3 variables and gives you 3 components, which it's just the gradient of the function, right? But this is a particularly important kind of vector field now because these are important to physics, and these will be important in a section later, right? So what we say is if f, some vector field, right? Actually, I want to say this. If f equals the gradient of f, little f, for some function f, right? So this could be of 2 variables, it could be of 3 variables, okay? Then this big F, the vector field, is called conservative. Right? Now that's a very, very important kind of vector field. Right? So you've maybe heard in physics classes, under a conservative force or something like that. Right? A typical statement might be is if you move a particle around a closed loop, in other words, you move something around and you end back where you started, then the total work you should have done is 0, right? That's not true if the vector field isn't conservative, right? It's kind of an interesting thing here, right? And we'll see why that's true in a couple videos when we talk about fundamental theorem of line integrals. Okay? So we also have a terminology for f. Little f is called a, if you like, scalar potential function. Of f, 4f. Let's say 4f. All right? So you might ask, is there a way to check whether a vector field is conservative? And is there kind of a routine way to find potential functions? The answer to both of those is more or less yes, right? There are ways to check if something's conservative. And then if it is conservative, there are ways to try and find a potential function. Now, it's pretty easy in 2 variables. It can get a little tricky in 3D. Okay, so that's it for this section on vector fields. In the next section, we'll start talking about line integrals and getting into some actual physics. All right? See you next video.